Welcome back, everyone. In this video, we're going to talk about solving rational equations. And so our strategy for solving rational equations is actually to transform them into different types of equations. And the way we're going to do that is by clearing the denominators, by multiplying by the least common denominator between the rational expressions involved in our equations. The idea is if we multiply by this LCD, or the least common denominator, that'll clear our fractions and turn our rational equation into just some simpler polynomial equation that we can then solve. The one thing we have to keep in mind, though, when we're solving rational equations is we are required to check our answers, but not super thoroughly. All we really have to make sure is that the answers we end up with after solving our transformed rational equation don't make the original rational equation involve division by zero. So once we get our x values that solve a rational equation, we just look at those x values in our original equation and make sure that if we plug those x values into our original equation, they don't cause division by zero. If they do cause division by zero, then those are what we call extraneous solutions, and we don't include them in our final solution set. So with those notes in mind, let's go ahead and try to solve this rational equation. We have 1 over x plus 1 over 3 is equal to 1 over 2. And so the first thing we have to do is find a least common denominator. That is the expression that involves all the unique factors of the denominators involved and no extra factors. And so we can see that our LCD is going to have a factor of 3, a factor of 2, and a factor of x. And so we can see that our LCD is going to have to be 3 times 2 times x, or 6 times x. All right, so now we've identified that our least common denominator, or LCD, is 6x. Our next step is going to be to use that LCD to clear our denominators and get rid of the fractions. And so we're going to multiply both sides of our equation by the LCD, or 6x. And we have to distribute that factor of the LCD, or 6x, to every term or piece of our equation. So that first fraction, 1 over x, is going to look like 6x over x after we multiply it by the LCD. If we take 1/3 and multiply it by 6x, we're really just multiplying the numerator there, and that'll turn into 6x over 3. And it's going to be equal to the right-hand side multiplied by 6x, which is 1/2 times 6x, which is initially going to look like 6x over 2. And so now if we've done this correctly, we should be able to cancel common factors and get rid of all these fractions and all of these denominators. So let's go ahead and see what happens. So our first fraction has a common factor of x that cancels out, and we're left with 6. Our second fraction, 6x over 3, can be reduced down to just 2x by dividing 6 by 3. And similarly, on the right-hand side, we can divide that 6 by 2, and our right-hand side simplifies to just 3x. And so now we've transformed our rational equation into this nice little linear equation. We can solve it in just one more step by subtracting 2x from each side. And when we do that, we get 6 on the left-hand side and a single x on the right-hand side. So x equals 6 is the potential solution to our rational equation. We just have to make sure now that if we plug x equals 6 into our original equation, we don't get division by 0, and we don't. We get 1 over 6 plus 1 over 3, and that is, in fact, equal to 1/2. So we found the solution to our rational equation. Remember, our process or our steps are we find the LCD, we use the LCD, or least common denominator, to clear all the fractions involved by multiplying both sides of our equation by the LCD. After we simplify that equation, there should be no denominators or fractions. We then solve the resulting equation and check to make sure that our solutions don't cause division by 0. If they do, we kick them out. But if they don't, then they are, in fact, the correct solution to our rational equation. All right, everyone, let's go ahead and look at another example of solving a rational equation. This time we're looking at x plus 11 over x squared minus 5x plus 4. When is that equal to the difference between 5 over x minus 4 and 3 over x minus 1? So to recap our strategy for solving rational equations, first we factor all of our denominators to help us find the least common denominator. We then use that least common denominator to clear the fractions by multiplying both sides by that least common denominator. We solve the resulting equation, and we double check to make sure that the answers we get don't cause division by 0. Okay, so let's go ahead and start by factoring all of our denominators. The ones on the right-hand side are already factored, so we just have to factor x squared minus 5x plus 4. So to factor this, we got to think of two numbers that multiply together to give us positive 4, and those same two numbers have to add together to give us negative 5, and those are going to be negative 4 and negative 1. And so now that we have factored that first denominator, we can see all the factors of all the denominators, and our LCD actually is just that first denominator in its factored form, x minus 4 times x minus 1. And so our next step is to multiply both sides and all the terms in our rational equation by that least common denominator, x minus 4 times x minus 1. So our left-hand side is x plus 11 initially over x minus 4 times x minus 1. I'm just writing that original denominator in its factored form. And now we have to multiply it by the LCD of x minus 4 times x minus 1. And that's still going to be equal to the second fraction multiplied by our LCD. So that'll look like 5 times x minus 4 times x minus 1 over still x minus 4, at least for now. And then the last fraction, negative 3, also has to get multiplied by our LCD. Let's see if we can fit it in here. Negative 3 times x minus 4 times x minus 1, but it is all just over x minus 1, at least for now. All right, so we've multiplied both sides of our equation by the least common denominator. Now we get the fun part of canceling common factors out. And all the denominator factors should cancel out if we did this correctly. Let's go ahead and see what is left over. On the left-hand side, it looks like we just have x plus 11. On the right-hand side, we have 5 times the quantity x minus 1. That's what's left over from that first fraction. And from the second fraction, we have negative 3 times the quantity x minus 4. And so now we have cleared the denominators and we just have to solve this resulting linear equation. Let's go ahead and finish expanding things. So left-hand side, we're leaving as x plus 11. That first piece of the right-hand side, we can expand as 5x minus 5. We can also expand that second piece and be careful when doing so. When we distribute that factor of negative 3 to the first term, we get negative 3x, but then to the second term, we get double negatives, and that turns it into positive 12. So let's carry on our work over here. Let's go ahead and just combine like terms. So we're leaving that x plus 11 alone, at least for one more step on the left-hand side. On the right-hand side, we have 5x minus 3x, which gives us a total of 2x on the right-hand side. We also have negative 5 and 12, which gives us a total of 7. And so now we can subtract x and subtract 7 from each side. And that'll give us our final answer. It looks like that gives us an x on the right-hand side and a 4 on the left-hand side. So our solution occurs when x is equal to 4. But remember, we have to check our solutions. Let's see if we plug 4 into the original equation. Do we get division by 0? It looks like we do. We're going to get division by 0 in 2 of our fractions, and it only takes 1 division by 0 to kick our solution out. So x equals 4 actually is not a solution to our original rational equation. It's the only one we found, though, and we just had to kick it out of our solution set. And so that means we have no x values in our solution set. So this rational equation actually has no solutions.